So, much like I did with parametrics, I wanted to do a quick review of vectors. Vectors are pretty straightforward. In calculus, we like to use vectors in component form, where we're given how much we are moving in terms of x and how much we're moving in terms of y's. They don't have to be called x's and y's, but it's that same idea. So if I have the vector -1 radical 3, it means starting at the origin, I would go -1 in the x direction, radical 3 in the y, and it's actually the movement of it. So it is always drawn as an arrow with the tail end, unless told otherwise. Our tail end starts at the origin, the arrow points and stops at the place our component form tells us. I know if you've taken physics, physics tends to do things in terms of magnitude and direction. To find the magnitude, first of all, notation-wise, magnitude looks like an absolute value. And the reason is because magnitude means the same thing. We are talking distance from zero, which is what an absolute value is finding, distance from zero. The difference is absolute value finds it on one number line. We are working in two number lines, two dimensions. The x-axis and the y-axis are two different number lines. In practice, what this means for us is we're getting a scalar, which is a not vector. It's one number that is the length of our arrow. In other words, we're doing distance formula or Pythagorean theorem. So this would be the square root of -1 squared plus the square root of 3 squared, which for our case would be square root of 1 plus 3, which is 2. To get direction, this typically is where trigonometry is involved, in that if we were to draw a right triangle, this was 1, this was radical 3, we know this is 2. What we get is the angle here would be pi over 3. So we could say that this is pi over 3 radians north of west. Or we could say that it is pi over 6 radians west of north. Within calculus, it's rare to be talking direction in this way. It's why we normally just use component form. Magnitude we do take advantage of because it's a way to give us the length of a vector, and which is really just doing our Pythagorean theorem.